So logic and proofs. So inside this topic, we have few sections. I categorized into 9 sections actually. We are going from the first one. We might jump accordingly, but we are going to discuss all of them. So divisibility of integers, that is important. Direct proof, proof by contrapositive, contradiction, converse, and count examples, inequalities, telescopic series, and mathematical induction. I'll tell you, the most important thing you are going to get is this, right? And then these two are important. Actually, these 4. So those 5 are important, very important. Mostly you get from the section 9, mostly, right? So now let's go into the divisibility story, right? So we have to prove this expression is divisible by a number, right? So I categorized some pathways of doing it, but I'm going to show you doing this example number 1, and then you will understand how to use these instructions. Now you can see factors, multiples, and divisibility proof. So when you have a question like this, you try to make factors or multiples so that you can look into the divisibility, okay? So very easy concept. Let's look into this one. So prove that n to the power 3 minus n is divisible by 3 for every integer n. Okay, so let's think about this one. So prove that n to the power 3 minus n is divisible by 3. So how do you do that? How do you do that? N to the power 3 minus n, you can factorize n squared minus 1, right? Then what you say? You say let, right? Let every integer n, right? So n is an integer. So let n is equal to 3k, right? Let n is equal to 3k. Why you include 3k? Because you need to divide by 3. So you try to construct it in this way, right? So then it's going to be 3k. This can be n minus 1, n minus n plus 1. So it's going to be 3k minus 1, 3k plus 1, right? 3k minus 1, 3k plus 1. Now this is a multiplication. So you can see 3 in front of it. So from here you can say this statement is divisible by 3. Divisible by 3. So divisible by 3 means this should be able to divide by 3 like that. So you can, why? Because there is a 3 in front of it. So it goes with our construction. So for every integer n. So since n is an integer, so you can do it in this way. Yeah. K is integer. Okay, so let's do this one using that knowledge.
Can you tell like also 3k plus 1 and 3k plus 2?
Why?
Because n is if like n is 5, let's say there's 3k. When you share like all
You have to. You have to. You have to. You have to. Let me do that as well. So what you are saying, so when you consider n to be 3k, right? So since it's divisible by 3, so you have to consider 3k plus 1 as well. So if you do 3k plus 1, what would be that? Then it would be n to the power 3 minus n is going to be, if it is 3k plus 1, this is going to be 3k plus 1, 3k plus 2, right? So again, it is divisible by 3. We'll discuss this in a minute. Then also you have to check for the next one, 3k plus 2, right? 3k plus 2, right? So that would be again n3 minus n is equal to, you get 3k plus 1. If you do that, you get 3k plus 1, 3k plus 2, and 3k plus 3. So 3k plus 3, you can take 3 out from here. So 3k plus 1, 3k plus 2, times you take 3 out, k plus 1. So since you see 3 here, again this is divisible by 3. Right? Now, why we do that way? Who can explain to me? Why we try n is equal to 3k? So there is a clear logic between why we are taking n is equal to 3k. Why? Because we need to divide by 3, right? So this 3k pops up somewhere like this, so then you can divide it, right? So that's the whole point of having 3. So if it says divisible by 5, obviously you're going to make it by 5 like that, right? So who can tell me the logic behind the other two? Why we are doing that? Yeah, I can hear you. Right. Yeah, that's the reason. Because k is integer, so you are just looking at the multiples of 3 only. What about 4 and 5? So that will be covered from these two. Yeah. Good. So example number 2. Divisible by 8. Okay.
Yeah.
Right. So is there an easy way to do this one? This question number 2? Eh?
Yeah.
How to do that?
It's like expand.
Expand it, huh?
Then you get like 8 and then. So
Yeah.
and then is
So if you expand it, it's going to be 4m squared plus n squared plus 4mn. Yeah. How come? How come?
they get different times.
Okay.
Yeah.
Can you?
Yeah, because
You can, eh? You can, eh? Difference of 2 squares you can use.
should be right.
Yeah. Yeah, do whatever you like.
Yeah.
Eh? Yeah, 4mn. So if you simplify this, what you get? 8mn. So obviously divisible by n, 8. Good. Next one. Show every square is of the form of this. Square numbers of modulus 5. So how do you do that? Show every square is of the form of this.
You have to show that it is in the form. You have to put them. You have to divide in it.
Show every square. Show every square of the form of 5k. Okay, how do you do that? Let's think about every integer, n is in the form of, we'll change the variables, 5m, 5m plus 1, 5m plus 2, something like that. So every square, okay, so it's going to be 5m square. 5m square is going to be 5 times 5m squared. Okay. Yeah. So, and then if you think about this as k, this will form 5k. Then let's try 5m plus 1, 2. So that would be 25m squared plus 10m plus 1. So that would be, you take 5 out. So it's going to be 5m squared plus 2m, right? Plus 1. So that would be 5. Right? So 5k plus 1 type, right? 5m plus, yep. Yeah. So let's check the other one. 5m plus 2, let's see, squared. So that is going to be 25m squared plus 20m plus 4. So take 5 out. So if you take 5 out, so it's going to be 5m squared plus, what do you get? 5m squared plus 4m plus 4. So this will form 5k plus 4 type. Right? And then let's see 5n plus 3. Let's see that. That would be again 25m squared plus 15m plus 9. So it's going to be 5m squared plus 3. Is that 3? So it's not, it's 30, right? 30. So it's going to be 5 plus. That's going to be, yeah. Yeah. 5m plus 4. How much is that? 25m squared plus, how much is that? 40 plus 16, na? How much is this now? 5m squared, 8 plus 3 plus 1, eh? That's going to be 5k plus 1, right? So you can keep going if you want. Yes. Yeah, I got to 4. So now what is the conclusion? What is the conclusion now? Hmm? So square are never of the form, 5k plus 2 and 5k plus 3. Yep. Okay. So, okay, so that part, that's how you do those questions. Right. So I'm going to leave all of these questions for homework. So here we assume the hypothesis to reach the conclusion, right? So key definition, if P, then Q. So P implies to Q. P is the hypothesis and Q is the conclusion, right? So it's true or false thing. So direct proof, assume P is true, then deduce Q using valid logical steps. Okay, so there is example here. Now we will go into another worked example and then see how it works. Show that if n is odd, then n squared plus 8n plus 3 is even. Assume n is odd, then n is 2k plus 1 for some k integers. Okay, how to do that? Right, how to do that? So assume n is odd. Assume n is odd, right? So then n is equal to 2k plus 1 for some k integer. So that is given to us, right? So you write n to the power 2 plus 8n plus 3, right? So n is equal to 2k plus 1. So it's going to be 2k plus 1, you substitute, plus 8, 2k plus 1, plus 3, right? Then you have to simplify this. So it's going to be 4k squared plus 1 plus 4k plus 16k plus 8 plus 3. So if you simplify this, you get 4k squared plus 20k plus 12. So you take 2 out. So then it's going to be 2k squared plus 10k plus 6, right? So this is 2 times, here you get integer. So it is given. Okay. So sum of consecutive integers, show that every odd integer is the sum of 2 consecutive integers. Let n be odd, then n is equal to 2k plus 1 for some integers, right? Show that every odd integer is a sum of 2 consecutive. Okay, so this is easy, right? So sum of consecutive means you can take k plus k plus 1. So sum of consecutive. So this is going to be now n, right? And that n is odd, it is given to you. So sum of 2 consecutive, right? So this is now, when you simplify, it's going to be 2k plus 1, right? Yeah. So n is equal to sum of consecutive integers k and k plus 1. Yeah. So prove that if m and n are perfect cubes, then m, okay, so let m is equal to a to the power 3, n is equal to b to the power 3. So mn is equal to ab, the whole thing to the power 3. So since ab is an integer, right, then mn is a perfect cube. Okay. So that's pretty simple. Now I want you to do this one for homework as well. So then I will check and I will help you accordingly. But you guys have to do it. So you have 40 questions to do, so I'm not going to discuss any further.